Hello everyone, and welcome to this series about machine learning. I've been trying to do a series to introduce this technology in a simple way, and I've been struggling to find the right setup for everyone to actually do the work. I've tried to make some kind of a virtual machine, and it was just too large to make it available online for people to download it. I tried a few approaches and they were not that successful, but finally I found a simpler way to make everyone participate using Amazon Web Services, AWS. So, what is machine learning actually? Using data instead of logic to teach a computer to perform tasks. So, if we take an example of face detection, instead of writing the logic to define how to detect a face, what is a face, its eyes and nose and mouth, and how to describe them to a computer, instead of doing that, we use a lot of faces and we feed it to an algorithm that finds what's common between faces and learns to find other faces later. That's actually implemented in your phone. Once you open the camera in your phone, you'll see a little box surrounding faces. That's face detection using machine learning, working on your phone. So let's jump into the system and see how can we set up our environment. So this lesson will be about setting up the environment. This is the hard part. We have to go through the basic things so we can get our environment running, and then we can start doing some of the more fun things. Basically, what we'll learn in this lesson is how to deal with AWS, Amazon Web Services, as a platform. We'll learn the basics of programming in Python. We'll learn the basics of our IDE, which is ipython notebooks. We'll learn few functions from two libraries, Numpy and pandas, and finally we will go through administration monitoring with Agenti, which is included in this image. Thanks to Agenti for giving us the ability to include their product in our image free of charge, actually. So shout out to them. Let's start with creating our image. We'll be using Amazon Web Services. Go to aws.amazon.com. If you don't have an account, open one. You can open a free account. So let's do that. Once we're there, we'll go to My Account console and open AWS Management Console. Once you're there, you'll see a lot of services. The one that we will be using is called EC2. Click on Launch Instance. Once you're in Launch Instance, go to Community AMIs and then look for ipython notebook server. I uploaded this AMI and made it public. It has all the tools that we will need to start with the machine learning. So let's select this AMI. For all purposes of going through this tutorial, I will be using, you can use the micro instance, which is part of the free tier, you have 750 hours of free access to this instance. So you basically can have 4 running instances for the complete month for free. And this is available for the first 12 months of your account sign up date. So we will go with the micro instance, and we don't have to go through every step. We'll just click review and launch. One thing we have to change is once we go down, we'll see security groups. And under security groups, we see that we have only one port open in our firewall to SSH access, and we need actually to open a couple of more ports. So click on edit, and once you're here, click add rule, and open both ports 8080 and port 8000. Make sure it's anywhere source, so you make sure you can access it. Click again on review and launch, then launch. If you already have a key, you can use your key. If you don't have one, if you have a new account and you don't have a key yet, create a new key, give it a name, download the file. It's a PEM file, and we will not use it in this lesson, but you need to download it and keep it so you can use it later to access SSH. For the time being, I'll use my existing key. I will acknowledge that I cannot access my instance without having the key, and I will launch the instance. I can go to view instances, and this is the new instance that's initializing right now. I will name it so I can access it and identify it later easily. I will name it lesson 1 and save. In here you will see the status of all your instances that's running on the system. If you have one right now, just wait for status check to finish initializing. You can access your instance by going to this IP. We opened 2 ports, 8080 and 8000, but we will start with port 8080. So we'll open a new tab, and we'll paste our IP colon 8080. And now we have successfully launched our own server with all the tools that we need to do machine learning operations. The password, the default password that comes with the system is Roshan, so it's ROSHAN, Roshan, and login. It comes with a few lessons in the system, but the only complete lesson right now is lesson 1, so we'll open that. It might take a few seconds to load because it's a big file, and your browser might take some time to render and download all the content of the page. But anyway, once it's up, we have access to our own Amazon Web Service instance, where we can do machine learning operations basically. An alternative setup is to do a local setup. I advise people to use Ubuntu on a virtual machine, and install Python dev, Python pip, ipython, Numpy, scipy. Actually, few more would be pandas and scikit-learn. Um, and to start your instance of ipython, just type ipython notebook. But this approach is much easier. I might record something later on how to set up your own local environment um, if someone actually demanded that. But anyway, now we have our environment. The first thing to actually learn is Python. We'll be going through Python. We'll learn just the basics, but if you want to um, really get into Python, I advise you to go through this book. It's 50 chapters. It's really quick read, and you will very much enjoy going through this book. Um, so let's start examining some code. We have where we can assign variables without declaring them in Python, so we don't have to declare a variable before we use it. So we can say x equals 10, y equals 5, z equals x plus y, and print z. That will print 15. To execute anything inside your code cells, press shift and enter. Shift and enter will execute the code inside your code cell. An alternative way is to go through cell and run, and that will run your cell. Another type of variables that we have in Python is strings. So if we have word2 equals hello, word1 equals hello, word2 equals Python, and sentence equals word1 plus space plus word2, then we print sentence, we get hello Python. So let's do some math. Variables that we defined in a previous code cell will still be accessible in other code cells. So if we defined x and y in here, we can still access them in here in another cell. So we have x plus y, x minus y, x multiplied by y or times y, and x divided by y. And once we execute that, we get 15, 5, 50, and 2. Another thing that we have to know is string formatting. We use percentages to have a placeholder for a string inside our string, so we can insert another string value there. So we can say just hello space percentage sign s, and save that into a variable called template. Then we can print template percentage, and we pass the second string to template, which will replace percentages. So the output of that would be also hello Python, where Python was replaced in template. We're printing actually template and replacing the percentages using percentage, then passing the word Python. You can definitely change things here and try other things. You can change hello to hi, and execute that, and you will get hi Python. So you can change code and test ideas as we go. You don't have to do the same exact things that I did. So let's use string formatting to improve the math results we get here. We get here 15, 5, 20, 50, and 2. And we have to say like 1, 2, 3, that's 1, 2, 3, that's multiply, so 50 is multiply. So let's start by trying to replicate this. Add result, um, and we have a placeholder for a string, and we're passing um, x plus y. Subtract result, and we have a string placeholder, then we're passing x minus y. With multiply, we're passing x times y. With divide, we're passing x divided by y. So we can, once we execute this, we'll get our results. Add result, subtract results, result, multiply result, and divide result. And we can know each number, what kind of result is it. We can pass multiple parameters to a string. So if we have a template that has 1, 2, 3, 4 placeholders, so we have, so basically we want to replicate this. It's 10 plus 5 equals 15, 10 minus 5 equals 5, 10 times 5 equals 50, 10 divided by 5 equals 2. So we want to have a place for the first number, a place for the operation, a place for the second number, and finally a place for the result. And this is what our template does here. It has 4 places: the first number, operation, second number, and result. To pass multiple variables to a string, we use brackets and put commas between our variables. So we go print template x, comma, plus, which is a string, comma, y, comma, and finally the result of x plus y, then x minus y, and passing negative in here, or subtract, x times y with the right operation, x divided by y, and passing the right operation, and that generates this result. One more concept that we have to go through. We can have multiple values in one variable or one object here. We have lists, we have tuples, and we have dictionaries. Lists and tuples basically do the same thing, not exactly, but we will not get into the technical details of the differences between them, but you need to know about them. You need to know there are lists and tuples in Python. The last one would be dictionaries, where we not only store single values like 1, 2, 3, 4, 5, but we can have pairs of key and values for each item in our dictionary. So it can be, for example, each employee's name and then their each employee's ID and their name. It can be any pair of values, basically. It can describe a single person, like it has one key for name, then his name, then for example age and his age, and gender and their gender, blah blah blah. So let's see how do they work. We defined a list, we defined a tuple and a dictionary in here, and we will be printing few things about them. First, we'll be printing the list. We'll just pass the list to a string using formatting. Then we'll be measuring the length of that list using the function len. So len, then the name of our list, which is numbers list, will generate the length of that list. We can access individual items inside our list by specifying their index inside the list. Their index start with 0, so the index of this one is 0, and the index of the last one is 4. But we can access the first item easily by saying 0, and instead of measuring the length of the list to access the last item, we can use negative indexes. Negative indexes would start from the last value. So -1 represents this number, -2, -3, -4, and -5. Tuples basically work in the same way. Finally, dictionaries. We can still access their values by using the method values, which returns a list of values inside the dictionary. We can access their values with values, and we can access their keys with keys. So if we change this into keys, we'll get the keys of the first key and the last key of this list. Because this is the same, that doesn't make any sense. So I'll just change this one to 66, for example. So if we use values, we would get first item 66, and if we use keys, we'll get our first item as 1, which is the key of the first item. The second thing that we want to get into is IPython notebooks. Up to here we have went through the main concepts and ideas of Python. We'll still have to learn how to do loops and if conditioning, and other things that we will learn as we need, actually. So we don't have to go through every aspect of the language in the first lesson. But the second thing that we will be learning about is IPython notebooks. IPython notebooks is basically a development environment that we're actually working with right now. This actual lesson is inside an IPython notebook. So this is what we want to learn, how to use this environment. IPython notebook allows us to have very interactive development environment. As we see, we can change things and we get instant results. The second thing that we have in here is latex, which allows us to format functions in a more readable way. So instead of this, we can have this using latex. You can actually double click in here and see the actual code that I used to write this function. There is a wiki page for latex language, so if you need to make your functions very readable to non-programmers, you can go through the latex wiki and learn how to do every trick to make your functions more readable. I spent too much time. Anyway, it allows us to work with the charts. A great place to start with and to have as a reference, and it's just an awesome place to go to, is this link, the gallery of Matplotlib. It has so many ideas and charts. They're all open source. You can go to any of them and learn how did they do that very specific chart. So if you're interested, for example, in making this chart, you can see the code in here and know exactly how did they write this chart. And the code is there for every chart in the gallery. You can copy basically this code, paste it in IPython notebook, hit shift and enter and execute it, and you will get this chart. So how to work with charts? First thing we need to do is import the Matplotlib library. This is a line that we will be using almost in every lesson. Import matplotlib pyplot as plt. So we're importing this module from this library, and we're giving it a short cut name as plt. So whenever we want to reference this, we'll just reference it as plt. So let's see how does that work. We have x as a list. It has 1 2 3 4 5, then y with 3 2 5 0 1. First we'll go with plt that scatter. This will scatter x and y. To know the format of before we scatter, actually we'll plot it. To know how to use any function in IPython, hit shift and tab, and you will get this really cool help that it's the doc string of the function. Basically it's a little help to give you information about this specific function. So once we want to execute this cell, we'll hit shift and enter again, and we will get our chart. Basically it plotted x over y. X was 1 2 3 4 5, y was 3 2 5 0 1. So we can have our charts in line, and we can visualize our data within our development environment, which is IPython. We can scatter. So scattering x over y will give us 3 2 5 0 1 again. We can add extra parameters to scatter. C for color, and I will make C equals to y. So the higher the number, the colors will change accordingly. Introducing one more thing is marker. We can use the parameter marker to change the markers in our scatter. The complete list is available in this URL. And S for size, you can, or scale actually, you can scale your markers up or down. So we can say, for example, we want to make it 800, and this will generate bigger stars. If we go with 80, that will generate much smaller stars. Well, this is a teaser for a 3D chart using Matplotlib, which is this. I will not be discussing how to build this chart. It's available in the gallery. If you go to the gallery of Matplotlib and scroll down to 3D Matplot 3D, you will find this example in here, and you will find a lot of other really nice examples to work with, but we will not be discussing this specific technique today. Two more tools that we will be working with are Numpy and pandas. They're very powerful libraries for Python to deal with large amount of numbers. So to multiply 2 by 10 is 20, that's simple, but to multiply a list with 100,000 numbers by another list that is another 100,000 numbers, and we need to multiply each corresponding numbers and get the result of that. that might be a very time-consuming process using pure Python. So once once we are dealing with large numbers, we will be using Numpy and pandas. As we imported the charting library before, Matplotlib, we will import Numpy and pandas, Numpy as NP and pandas as PD. Always try to um, create shortcuts for your libraries, because everyone else uses those short handles to access the libraries. So your code will be very compatible with other people that you might be working with. One important function that we use is arrange. It generates an array. We can specify starting number, ending number, or just an ending number. So in here, we created an array of 100 numbers. It starts with 0 and ends with 100. We will use another function called reshape to reshape this array into a 10 by 10. So instead of being 1 by 100, it will be 10 by 10. And this is all actually NumPy. We will be using a very important object in pandas called data frame. It represents basically a table, but it's a very powerful and fast table that you can work with, and you will be finding a lot of people working with pandas data frame for really large amounts of numbers. So to define a data frame, we can pass our NumPy array to the data frame, and it will take into that array and convert it into a data frame. And we stored it as df, short for data frame. Then we're printing the data frame just to visualize it. So these are keys. The first column in here and the first row are keys. So the key of the first column is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same for the rows. And it tells us that it's 10 by 10 rows and columns. Let's see how can we perform some operations on our data frame. So we can access the first column, which is the second column, which is column number 1, minus df of 0, which is the first column. So it's subtracting the first column from the second column, and that would be 1 minus 0, which is 1, 11 minus 10, which is 1, 21 minus 1, which is 1. So we can see the result is going to be 1 for all values in here. Then we're adding them together and getting the results. We can multiply and we can do all kinds of operations, and we will get really fast results using pandas. One more thing that we use pandas for is to read comma-separated value files. It reads files from the local system, which is located on Amazon instance, and it can fetch comma-separated value from the internet directly. So let's see how can we upload a file first into our system and see how can we read it. To upload file into the system, we'll be using our administration monitoring tool, Agenti. To access Agenti, go to https yourip:8000. So let's open this. It tells us that there is nothing called your IP or DNS. So let's copy our IP and paste it here. Make sure you paste it over the complete word and hit enter. It will give you a warning depending on your browser. You might see a different screen telling you that this product is using a certificate that's not verified, um, or not signed by someone who's verified. So just add an exception for this. It will basically protect you sending passwords over the internet. But this is a very safe way to do it, but the license is free, so it's not signed by a verified source. To log into Agenti, we will use username root and password admin. Make sure you change your username. At least change your password after you log in. The first thing you do after you log in, you want to change your password. This is very critical. This is very critical. Go to password and change your password. Put admin in here and put something else and save. Make sure you do that. You don't want to have your Agenti access available to everyone on the internet, unless you have protected yourself with firewall and specified your exact IP, but that would be a much harder approach. And if you're ready to go through the trouble of changing that, I think it would be much more beneficial to change just the password in here too. Anyway, to access our file system, we will go to File Manager. On our File Manager, this will access our main storage of the system. All our files are stored inside Home, then Ubuntu. Everything you're working with, including your ipython notebooks, are available in here. You will see a lot of hidden files that the system uses to do one operation or another. The important one is the data folder. Open the data folder, and you can upload a comma separated value file into your system. You can have one from work or download a sample one from the internet with some numbers to upload it into the system. It can be stock prices, it can be something scientific, it can be the NASA exoplanet format, it can be whatever you want it to be, whatever you're working with, and you can upload a file into the system, and this way you will have it stored into the system and you can access it later to do some machine learning processes with it. To read files that we upload into the system, we use pandas. So pd again dot read csv, which is short for comma separated value, and then go double quote data / then your file name. So whatever the file that you uploaded, you want to access it. If you want to access the data and load it, you can access the data later on csv underscore data. You can change that with a URL to where a file exists on the internet, or it might be an API that generates comma separated value results, and you can fetch that directly from your pandas and have it loaded into the system where you can process it and do so many wonderful things with it. This is the end of lesson 1. I hope you enjoyed it, and let me know if this is clear, and if you have any questions, keep it in the comments below, and I hope to see you next time. Thank you.